Good morning, all. My name is Yolanda Nkalashe. I'll be talking around interpretable natural language processing for classification of misinformation data. So, in the past couple of years, there has been a focus on explainable AI models which are transparent and trusted, and which could also provide an alternate route for machine learning engineers to use compared to white box models when interpretability is required. Our main focus is on natural language processing tasks as they are more complex in nature and require state of the art black box models to achieve the desired accuracy. The aim is to achieve interpretability in our natural language processing model, specifically for misinformation classification tasks. We aim to answer two questions. Can we use prototype selection to interpret how bird classifier predicts misinformation tasks? And secondly, what linguistic properties are considered when classifying? Just a little bit of background around explainable AI. So I'll first talk around the need for explainable AI. So there are three main items which come up from literature why we need explainable AI. The first being able to say for certain how a model reaches its decision. Secondly, being mindful of the end user, as the end user does not have the necessary knowledge that you, as the machine learning engineer, might have. And thirdly, regulation. There has been a lot of regulation, as can be seen in these articles here, around our machine learning models and what is fair. Secondly, in terms of the background of explainable AI, I'll talk around the classification of explainable AI. So, explainable AI can be classified into two self explaining models as well as post hoc explainability. So, self explaining means that the model is inherently explainable, whilst post hoc means that the model is black box and explainability can be achieved after the model has been trained. We can further classify explainable AI into global explainability as well as local explainability. So, global explainability determines how the overall model makes its decisions, whilst local explainability focuses on a single instance on how a prediction was made for that instance. There are four techniques which I've picked up from the literature that I've read in terms of explainable AI or interpreting your models. So the first one is interpretable models, which are models which are interpretable themselves, like your regression models, decision tree, or rule based models. Secondly, model agnostic. So, model agnostics are explainable AI techniques which can be applied to all models, even self explaining models. So, these techniques consist of line techniques, saliency of feature, importance, your layer wise relevancy, propagation, as well as your probing. Thirdly, model specific. So these techniques are very specific to this model type. So those techniques are layer-wise relevancy propagation as well as your attention maps. And then lastly are example-based techniques, which is prototype selection, influence instances, and adversary examples. So this is not an exhaustive list, but just an example of techniques or that can be used to achieve interpretability in black box models. So the methodology that we used was focused on example-based technique, and the main aim was to achieve global interpretability. We use the prototype selection methodology. So prototype methodology aims to understand and explain the data. This is achieved by selecting a sample of your data points that best represent the full data set. There are many approaches to select prototypes from your data. So you can have your clustering techniques, there's Bayesian techniques, as well as the maximum mean discrepancy technique to select prototype. In our approach, we use the MMD critic, which is the maximum mean discrepancy techniques, which was presented by Ben Kim in the paper Examples Are Not Enough. So this is a greedy approach. It selects prototypes that have a distribution that is similar to the data distribution. The MMD measures the difference between the two distribution. And the goal of the maximum mean discrepancy is to minimize the MMD. So the closer the MMD is to zero, the better the prototype fits the distribution. So this is just a formula in terms of that is used to select your prototype. So the main aim is to minimize and approximate this to zero. Once the prototypes are identified, we want to further understand the linguistic properties that are captured. So to do this, we use a probing toolkit, which is called Centerval. So Centerval is an evaluation toolkit for sentence embeddings, which allows you to evaluate linguistic properties which are encoded in your sentence embeddings. So these are the results which we have achieved so far. So the data set that we use is a lie data set, and we categorize the labels as pants on fire and false labels to be false, and mostly true and true labels to be true. So we first trained a BERT model to classify the misinformation and used the trained model to predict or validate with the test data. And this is the output that we got. So as expected, the BERT model did achieve well. And then once we trained our board model, we then selected our prototypes. So prototypes can be used before a model is trained to understand one's data, or after the model is trained to understand how the model makes its decision. So we selected our prototypes once after the model was trained. From the predicted data by BERT model, for each class we extracted the prototypes. We created two functions to extract prototypes and one to extract critics. So you need to select M, which is the number of prototypes. So in our case, we selected 10 prototypes to be selected, and we reduced the data to 20% just to get an example of the results. So the output of your prototypes will give you the index of your prototype in terms of your embedding, as well as the weight of the prototype in terms of which prototype actually weighs better than the other prototype. So we have the output result of the fake class prototype as well as of our true class prototype. And we also did part of speech tags as well as the center val output. So this is our part of speech tagging output in terms of comparing our true data set in terms of our true prototypes compared to our fake prototype selections. And then this is also our results in terms of our center val task for length prediction. So this task basically shows or gives you an accuracy in terms of how well the embeddings actually have the linguistic property for the length. So in our case, the length prediction accuracy was quite high in terms of the length of the text. We achieved accuracy of 80% for the center val task for length prediction. And what we did is we just drew up in terms of the average length across the prototypes compared from the true to the fake data set to see what lens could we have for our fake news and also our true news data. And from the result, we see that most commonly we find that our fake news data set has a short and more impactful length in terms of sentence compared to our true news data set. So what opportunities do we still need to explore? So firstly, we need to include more probing tasks and see what more linguistic properties are actually captured in our prototypes as well as our embeddings in terms of our BERT model. And secondly, if we can use prototype as an unsupervised classifier as part of a cluster technique, and how does its accuracy compare to other state of the art techniques? And thirdly, what insights can we get from a different type of data set, e.g., a data set which have a South African context? Thank you for listening.